In California, earthquakes are a fact of life, but why do they happen? Is it really true what they say about the big one? And what should you do if one hits when you're outside? We answer all these questions and more in Why Do Earthquakes Happen? The Science Explained. The ground beneath your feet may seem pretty stationary, but it's actually moving, shifting and sliding all the time. Even as we speak, tectonic plates, huge slabs of rock that make up the Earth's crust, are bumping into each other, sliding past each other and pulling away from each other. These interactions cause stress to build up along the boundaries or faults of these plates. When the stress is greater than the strength of the rocks break and the energy is released as seismic waves that travel through the Earth's layers, causing the ground to shake, and that is an earthquake. But how are earthquakes measured? Earthquakes are measured by a seismograph, which records the strength or magnitude of the earthquake. The most widely used scale to measure the strength of an earthquake is the moment magnitude scale. Moment magnitude, formerly known as the Richter magnitude, is expressed as a single number like 7.2. It indicates the amount of energy released by an earthquake. The moment magnitude scale replaced the Richter scale because it can accurately measure larger earthquakes that the Richter scale tended to. In addition to the strength of an earthquake, the modified Mercalli intensity is used to describe the impact or intensity of an earthquake. It describes the effects of an earthquake on people, buildings, infrastructure, and the natural environment based on the strength of the ground motions, and is often used to estimate the potential damage caused by an earthquake. The Mercalli intensity is determined by analyzing the data obtained from seismographs and by gathering information from people who experienced the earthquake. To understand the moment magnitude scale, let's look at the 2011 Japan earthquake, which had a magnitude of 9.0. In this example, the prefix mega refers to a million. So a mega earthquake releases 10 raised to the power of 6 times more energy than a unit earthquake. Each whole number increase in magnitude represents a 32-fold increase in amplitude, and about 32 times more energy is released. So a magnitude 7 earthquake is 32 times more intense than a magnitude 6 earthquake. The moment magnitude scale is a logarithmic scale, meaning that the values increase exponentially. So a magnitude 9 earthquake releases about 32,000 times more energy than a magnitude 6 earthquake. Earthquakes can occur anywhere in the world, but they are most common along the boundaries of tectonic plates. The Earth's crust is broken into several large and small plates that move and interact with each other. As the plates move, they can get stuck on each other due to friction. When the stress from the friction exceeds the strength of the rocks break and the energy is released as seismic wave. Let's take a closer look at the types of seismic waves generated by earthquakes. Seismic waves are divided into 2 categories: body waves and surface waves. Body waves travel through the interior of the Earth and are further divided into P waves and S waves. P waves are the fastest type of seismic wave and are the first to reach a seismograph after an earthquake occurs. P waves are compression waves, meaning that they compress and expand the rocks they travel through in a way that is similar to a sound wave. S waves, also called shear waves, are slower than P waves and arrive at a seismograph after the P waves. S waves are transverse waves, meaning that they cause the rocks to move side to side perpendicular to the direction that the wave travels. Surface waves are the slowest type of seismic wave and have the greatest amplitude. They cause the most damage during an earthquake and include love waves and Rayleigh waves. We couldn't do a video about earthquakes without mentioning the big one, the one everyone in California is waiting for. The big one refers to the expected major earthquake that will eventually hit the state of California. The San Andreas Fault is a major fault line that runs for about 800 miles through California. The southern part of the fault is in an area known as the Los Angeles Basin. According to the Southern California Earthquake Data Center, there is a 7 to 10% chance that a major earthquake, meaning a magnitude 7.4 or higher, will occur in the next 30 years in the Los Angeles area. Now that you know a little bit about earthquakes, here are some things you can do to stay safe if an earthquake happens when you're outside. If you feel the ground shaking, drop to your knees and take cover under a sturdy table or desk if possible. If there isn't any shelter nearby, protect your head and neck with your arms and try to find an open area away from trees, buildings, street lights, and utility wires. Once the shaking stops, check yourself and others for injuries, and then look for damage to the surface. Be prepared to help others who may be injured or trapped. If you were in a rural area, check for fallen power lines and other hazards. The largest earthquake ever recorded happened in 1960 in Chile. The earthquake had a magnitude of 9.5 and was so powerful that it generated a tsunami that caused widespread damage in Chile and other countries. The largest earthquake in the United States happened in 1964 in Alaska. The earthquake had a magnitude of 9.2 and caused widespread damage in Alaska and other parts of the west coast of North America. When an earthquake occurs, the energy is released in a series of waves that radiate outward from the source of the earthquake. The point where the earthquake originates is called the hypocenter or focus. The point on the Earth's surface directly above the hypocenter is called the epicenter. The energy released by an earthquake can travel through the Earth for many hours and even days. The strength of the waves decreases as they travel, but they can still cause damage and be detected by seismographs far from the source. In conclusion, earthquakes are a natural phenomenon that occurs due to the movement of tectonic plates and the release of energy in the form of seismic waves. They can cause significant damage to buildings, infrastructure, and the natural environment. Understanding the basics of earthquakes, including their causes, measurement, types, and effects, can help us better prepare for and mitigate the risks associated with these natural disasters. And remember the drill: drop, cover, and hold on. Drop to your knees and take cover under a sturdy table or a desk if possible. If there isn't any shelter nearby, protect your head and neck with your arms and try to find an open area away from trees, buildings, streetlights, and utility wires. Once the shaking stops, check yourself and others for injuries, and then look for damage to the structure. Be prepared to help others who may be injured or trapped. If you are in a rural area, check for fallen power lines and other hazards.